This shows the input DC pulse, and this is the AC output. Welcome back to the Vintage Electronics online course. It is very easy to convert AC into DC by using a rectifier. But can we convert DC into AC? This is DC, but we need domestic AC. We can convert DC into AC by using an inverter. An inverter is nothing but an oscillator. To explain what an oscillator is, I will show you this demo. In a battery, the positive terminal is always positive, and the negative is always negative. So, there is no oscillation. For manual oscillation, we need a switch that turns on and off at regular intervals. For 50 Hz, we need to switch on and off 50 times in 1 second. But this is practically impossible to do manually. We can only operate it 3 or 4 times per second. So, I modified this toy and attached the switch to it. See, this is the switch. This gear has 18 cuts. If I rotate it once, the switch operates 18 times. If I rotate it 3 times in 1 second, the switch operates 54 times in 1 second. By watching this demo, you will understand what an oscillator is. Now look at this LED bulb. There is no blinking because it is DC. That means 0 Hz. Now 1 blink, 2 blinks, and so on. If it blinks 50 times per second, that is 50 Hz. Many people have a doubt. If AC oscillates 50 times per second, why don't we see the light blinking? In older lamps, we could actually see this blinking. But due to the persistence of vision, which is about 25 frames per second, our eyes cannot distinguish it. See, we cannot notice the blinking in this LED bulb. This is 50 Hz, which is the domestic AC frequency in India. Now, I am connecting this setup to the 12-volt side of a transformer. See, this setup cuts the DC and feeds it to the transformer. But to the transformer, it appears like AC. So, it steps up 12 volts to 230 volts AC. When this rotates, the DC voltage is chopped and supplied to the transformer. So, the output becomes 230 volts AC. This setup acts like an inverter. This is to show the input pulse. See, when it rotates, AC is generated. We can achieve nearly 50 Hz. This type of input is called pulsating DC. If we touch the output while it is rotating, we will get a shock. Now, let's see an important point every service engineer should know. In houses, sometimes in an AC socket, the tester glows in both holes, live and neutral. See here, the tester glows only in the right hole. This is phase, and this is neutral. So always remember, the right side should be phase, and the left side should be neutral. Now consider this line coming from the EB post. I am cutting the neutral line. Now connect any load. The load will not work. If I test using a tester, it glows on both sides. This confirms that the neutral line has a problem. Now when the neutral is corrected, see, the tester glows only on the right side. Now, what is phase and what is neutral? In AC, both lines vary between positive and negative. But how do we identify them? At the power station, there are 3 phase lines and 1 neutral. The neutral line is connected to the ground. So in any location, the ground is partially neutral. That grounded line is always connected to the left side of the socket. So we can identify that the right side is phase and the left side is neutral. Normally, the neutral does not give a shock because it is the return path. But the phase line can give a shock. If there is no neutral in your house, you can take one line from deep earth and one phase line from the switchboard and connect them to a bulb. The bulb will glow with half power, because the earth acts as partial neutral. Now this is AC. And this is DC after rectification. But it has some ripples. This is how it looks, positive, then 0, then positive again. A capacitor is used to filter these ripples and produce smooth DC. See, this is filtered by the capacitor. This is a single diode rectifier. The blinking happens because of ripple in the DC. Now, when we add a capacitor, the blinking stops, and we get smooth output. This is called a filter capacitor. This is the battery DC waveform. And this is the capacitor filtered DC waveform. In the next video, we will learn about voltage, current, power, and the function of an eliminator. I hope this lesson is useful to you. Please train your children as well. Until the next lesson, goodbye.